and then I can review that for the next.
Let's see how much time we have, if we have time to work the whole thing. So first off, I just want to remind you, so there will be on the final, this practice final will be the same length as the final. So you'll see 35 similar questions. So that's the first question I get a lot. How many questions are on the final? So it'll be very similar to this. So let's just go over that. There's 35 questions on the final. It will be multiple choice and it's on the computer. Okay, just like you've done all all semester. So when that happens, you may use a calculator. I don't mind if you use a calculator, but it cannot be your phone. So if you don't have a calculator that is not your phone, you need to borrow one from the proctor. So also, I'd like you to use scratch paper.
Yeah, that'll work.
Scratch paper and a pencil. And my pen is not working very well. Scratch paper and a pencil. And you can get that. The proctors will have that. So also in the room, if you're a distractor or you get distracted easily, I suggest sitting not by the door. So think about where you're sitting in the room. So
yeah,
those are.
I sat away from the door last time. So.
You sat by the door last time?
Oh, I sat away from the door.
Oh, okay. Good choice. Yeah, think about your spot where you sit. And what else? Yeah, so those are and it will automatically show you your score when you're finished. So if you have questions, let me know. So yeah, you can expect 35 questions. It's not super long. I think last semester's was 40.
Yeah.
And then
I got it done really fast last semester too.
Okay, good. So you should be good. Any other questions on like the format or what to expect?
No.
No. Okay. So let's just go over some. If you're good with the first couple, let's go to the first one that you need help with. Do you want to start with this one's distributive property, right? Distribute to each term. Careful with the double negatives. Should we start with number 2?
Yeah, let's do that.
Let's start with number 2. Okay, Sal has goals. Sal has scored G goals this season. Ben has scored 4 times as many goals as Sal. Chun has scored 3 fewer goals than Ben. Write an expression to represent the total number of goals they have scored. All right, so let's look at this. So let's see. We've got 3 people here, right? Sal,
yeah.
Ben, and Chun. Hun. I forgot the C. All right. So how many goals has Sal scored?
It looks like he scored just G goals.
G goals. We don't know, but it's this number. This represents the number of goals he scored. All right. How about Ben?
It looks like he scored 4 times as many as Sal.
So how could I write that?
So maybe we can do 4G.
Good. 4 times G, or 4G, right?
Yeah.
And then how about Chun?
Scored 3 fewer goals than Ben.
Yeah. So what was Ben's goals?
Ben was 4G.
And then Chun would be 4G, and then what?
-3.
Good. Sweet. You did that awesome. Now we're going to write an expression to represent the total. So how would I represent the total? If I want
multiple choice.
Go ahead. What?
If you want multiple choice, I don't, because I have an expression written down and I don't see it on.
If you want it, your practice benchmark, are you saying you don't have a multiple choice?
I'm saying I've written down, it's not showing on here. Oh wait, does it mean you have to solve the equation?
So what I'm asking you is to tell me, how do I make a total? So I want to know together how many goals have they scored? What would I do? If I have Sal's, Ben's, and Shun's goals, how would I find out how many they scored together? Their total.
I would think subtract 3 from 4, but then the G's right there.
Okay, so let's just say, I'm going to give it to you like this. What if Sal scored 5 goals, Ben scored 20, and Chun scored 17 goals? How would I find out the total number of goals scored?
Add them up.
Yeah, so right here, you want to know the total, add them up.
Okay.
So G plus 4G plus 4G minus 3. You added them up. And then if you want to simplify this, here it is, G plus 4G plus 4G minus 3. You could simplify this. 1G plus 4G's is 5G's. 5G's plus 4 more G's is 9G's. So 9G's minus 3 would also be a correct expression. So if I wrote G plus 4G plus 4G minus 3, this would be correct. This would be the simplified form of that.
Okay.
So right here, the key is write the expression in simplest form. So they're going to trick you with a little, oh, this looks like it, but I didn't add my like terms and finish here. Okay, so that's what it looks like in simplest form. Be careful of that.
All right.
Okay, on to the next. What next one would you like to work?
Maybe just the third one.
Okay, which expression shows the factored form of this? Now factored, I always think of like you're undistributing. So think I'm undistributing. I did the distributive property. Now I got to walk back, right? I got to walk it back and do it backwards. So if I want to undistribute here, I want to see what term they have in common. So what is the biggest term that 15x and 4 have in common? This is kind of
I want to say 3, but 4 is a go with it.
Yeah, it doesn't. 3 doesn't divide evenly into 4. It does into 15.
But then also 2 goes into 4, but not into 15.
Yeah. So what do we think? Are there any numbers they have in common besides 1?
2. There's 2 numbers in common.
2 doesn't divide into 15 though, evenly.
So maybe.
So guess what? Tricky question. You can't factor this. They have no terms in common.
So thinking B would be probably the right answer.
What's that?
I was thinking B might be the right answer.
You'd like to do B as the right answer?
No, I was thinking.
Oh, you were thinking B. Let's see what B does. Check it. Check B if you're not sure. So go, all right, 3x plus 5x, then times 2 plus 2. Well, using order of operations, you do, please excuse my dear Aunt Sally, right? So yeah. Parentheses, then exponents, then multiply and divide are on the same level, and add and subtract are on the same level. So I'm going to do parentheses and exponents. There's none of those. So I do multiply, divide first. So that means I have to do this first. 5x times 2 is 10x. So I'm going to have 3x plus 10x plus 2. Well, 10x and 3x are 13x's plus 2, and that is not this. So it's not B.
Makes sense.
If you multiply this out, you get 15x plus 3. That's not that. If you multiply this out, you get 15x plus 20. That's not that. So tricky, tricky. It doesn't factor. Okay, let's go on to the next one. Let's go down and see how many we can do. Solve each equation, check your solutions. So here what we have is some fractions. A couple ways you can do this, depending on how you want to view it. 1/6 y equals negative 1/12. Your goal when you solve equations is to isolate the variable on one side so you can see what it equals. What is that variable? What is that guy right there? So right here I have 1/6 times y. So if I would like to get rid of the 1/6, I can multiply by its reciprocal, 6 over 1, or just 6. And I multiply this side by 6 over 1, or if you just want to multiply by 6, because 6 is the same as 6 over 1, that would eliminate that, because 6 times 1 is 6, and 1 times 6 is 6, so this is 1 over 1, and 1 times y is just y. And then on this side, multiply across the top and multiply across the bottom. Negative 1 times 6 is negative 6, and 12 times 1 is 12. This reduces. What does this reduce to? 6 goes into 12 how many times?
2.
Yeah, so this reduces to negative 1/2. Excuse me. 6 goes into 6 one time, 6 goes into 12 two times. So y is negative 1/2. Make sure you know how to work those fractions. Multiply by the reciprocal. All right, let's go to the next one. Suppose for some value of y, the solution for this equation is x equals to 20. What must be true about y? Well, we don't know what y is, but this equation, I'm going to write it down here so we can see it a little bit bigger. This equation has an x and a y in it. 0.5 times x, or 1/2 x, minus y equals 0. I have an x and a y. How can I solve this when I have an x and a y in my equation? How can I solve this? Well,
maybe input the x and then solve the y.
Good. You know what x is. X is 20. Put that in and then solve for y. So nice work. 0.5 times 20 minus y is 0. So 0.5 times 20, now I could do this on a calculator. I could think 0.5 is a half. So what's half of 20?
10.
10. 10 minus y, excuse me, is 0. Now I'd like to solve for y, meaning I need to get it by itself on one side of the equation. So what could I do here?
You could not subtract or add 10 to 0.
I could subtract 10 to both sides. I could do that. That would work, but then I'd have a negative 10 over here and a negative y here. Then I would have to do another step of multiplying or dividing both sides by negative 1. The easiest thing to do is just add y to this side. Then you have a positive y and a positive 10. That eliminates that, and you have 10 equals y. Check and see if that works. Okay, if 10 is y, and I go 0.5 times 20, that gives me 10. 10 minus 10, is that 0? It is, so it works. All right, on to the next one. It's number 5. Oh, look, it's 10 and 10, shoot. That's my bad, I should fix that. Well, both of those are right.
Oh, I didn't notice that.
All right, I gotta fix that. Sorry about that. I adjusted that problem and I changed some things around and I must not have fixed that. Okay, well, either B or D would be correct. So, okay, let's go ahead and look at number 6. 26 more than the product of a number and 17 is negative 42. Okay, 26 more than a product of a number and 17 is 42. I just want you to write that down. I'm going to say it to you and you write down what I say. Okay?
Okay.
26 more than a product of a number. What do you want to use for your number? You don't know what the number is.
Yeah, we don't.
So what do you want to use for that number? A number. You could
17, 20, 42, negative 42. That should be a clue.
Well, we need to pick a variable for a number because we can have it be any number. So what do we want to pick to represent our number?
N.
Okay, let's go N. So write it out. 26 more than the product of N and 17 is for negative 42. How does that look? 26 more than, so I'm going to go 26 and then I'm going to add that 2. It's more than it, so I'm going to add 26, right? The subtraction is a little harder because you have to do that at the end. You have to do that on the flip side. But 26 more than the product of a number and 17. What does that mean, product? Does that mean I'm adding the number to 17? I'm multiplying? What does it mean?
It means multiplying.
Yeah, it means multiply. So this is just testing to see, do you understand what product means? So the product of a number and 17. So I'm going to go 17 times the number. And I wrote the 17 first because it's easier to write 17n than n17. That looks weird. So 17 times n is. What does the is mean?
Equal to.
Yeah, is negative 42. So just write out how it reads. There you go. So which one would it be? 26?
It would be B.
There it is. So they switched these two around, but they're still equivalent. So yes, it's B. Good. All right, write an inequality for each sentence. So let's go ahead and do this. Her earnings at $11 per hour were no more than $121. Okay, that no more is kind of tricky. Think about what that means. If she earned $11 per hour, okay, her earnings were no more than $121. Does that mean that she made more than $121 or she made $121 or less?
$120 or less.
Yeah, so how would I write that? $11 per hour. So you would do $11 times the number of hours you worked. Say you worked 5 hours or 7 hours. Every week it might be different. So you put a variable there to represent the number of hours you worked. Her earnings were no more than. So that means if these are her earnings, no more than means it has to be less than or equal to this. So they have to be less than or equal to 121. Now, a lot of students hear more and they think greater than, but it says no more than. So that means it has to be less than. This word is telling, right? So careful with that. My daughter messes that one up all the time because she sees more and she puts greater than. So read it correctly and think about what it means. If I make no more than $121, that means I'm making 121 or less. All right. Okay, on to the next, number 8. Let's go through that one. Determine whether each relation is a function. Okay, so this one is just one relation. Now, how do I tell if it's a function? And this is like what I like to think about functions. I like to think of it as functional. This is how my brain works. If something's functional, that means it works, okay? That's how I like to think in my brain. So I like to think of it as I can have lots of different inputs into my function, and I usually call those my x values. That's what I'm going to input in here. And it's going to give me
a function mean it has to be a straight line?
It doesn't have to be a straight line. No. This right here is a function. And this is how I can tell. Every x value, let's just make a table. If I pick a 0 for x and I put it into my equation, or in this example, a function, I'm going to do the operation to it. Let's say, for example, let's go. My function is f of x equals 2x plus 5. Okay, in this particular thing, I plug in 0 for x. 0 times 2 gives me 0, plus 5, I get out 5 for y, which I'm going to call the function of x. Okay, the function of x is y, all right? So I get out 5. Well, let's say I plug in 0 again. Or let's plug in 1. I plug in 1 here. 1 times 2 is 2. 2 plus 5 is 7. Okay, let's say I plug in 1 again. I want to check it again. Is it still going to give me out 7 every time? Every time I plug in that 1, does it change its mind? Well, let's plug in 1 again. 1 times 2 is 2. 2 plus 5 is 7. It does. So this particular equation is a function, okay? Because every time I plug in that 1, it gives me out a 7. So what you want to do is look to see if your x values repeat, do the y values also repeat? Meaning, if I plug in 1 again and this time, let's try it one more time. Let's say this wasn't my function. I don't know what it is in my box. Let's say I have something. I plug in 1 again. This time it changes its mind and it spits out a 3. Well, that's not functional. You keep changing your mind. You can't change your mind. When I plug in 1, you always give me 7, always. So there's a test with a graph. It's called the vertical line test, right? If you draw a vertical line anywhere on this graph, and that was not a vertical line, that was a squiggly line. If I draw a vertical line anywhere on this graph, I should only hit it once.
Yeah.
If I hit it once, I have a function, right? And the reason is because if I were to have, let's say, I'm going to just plot what I just did. Let's say my points for my graph were 0, 5, 1, 7. Let's say it's up here. 1, 7 again. This time I plugged in 1 and I got out 3. Okay, here's 1, 3. When I draw a vertical line, for my x values I hit 1, 7 and 1, 3. When I draw a vertical line, sorry, I didn't draw through those points. Let me try that again. When I draw a vertical line, I hit 2 points. Okay, I hit twice. That's because this is not functional. I can't have an x value and get out 3, and then in that same x value get out 7. That's why the vertical line test works, because it tells me if I have 2 x values, the same x value, sorry. If I have the same x value, if I have 2 different y values. So it gave me out 2 different answers. So the vertical line test works to check to see if that x value gives out 2 different answers, 2 different y values. So just do the vertical line test. If you only hit once anywhere on the graph, then you are a function. If your graph went like this, let me see, try again. If your graph was like this, let's say a C, okay, a sideways parabola, I would hit it twice because I would have 2 different options for my x value. So that would not be a function. You can still graph it though. All right, so is this a function? It passes the vertical line test, so yes.
Yeah.
Yes, it passes the vertical line test.
You want to skip number 9?
Uh-huh.
Because it's like literally the same problem.
Yeah. The relation, so let's look at number 9. The relation is not a function when which ordered pair is added to the set. So what you're looking for is the same x value. Let's check. That's a 2, -7, -4, 3. As long as all these x values are different, I can't really even tell if it's a function. It looks good. Okay. What I'm worried about is if I have that x value that repeats and it gives me a different y value. I'm going to ask it the same x question and it's spitting out a different y question. So which one of these gives me a repeater for the x?
C.
Yeah, 2. I already put in 2 and I got out 17. This time I'm going to put in 2 and now it's going to spit out 6. That's not going to be working. That's not functional. This does not make my my operation a function because it changes its mind. I plugged in 2. This time I plug in 2 and I get out 6, so it would be C. All right, are we good on functions?
Yep.
Okay, let's go to the next. Find 4 solutions of each equation. Write the solutions as ordered pairs. So let's go ahead and look. We want the relation that is represented by this equation has this domain. Which of the following sets is the range? So that's weird. That little part above it doesn't go with it. Okay. I need to go and erase that. Ignore that part. I gotta fix 10. Sorry about that. I just put this together and I must have attached the wrong header to that problem. So ignore that part, just read this part. Okay, the relation that is represented by this equation has this domain. Which of the following sets is the range? So I'm going to plug in 1 and figure out what I get out for y. plug in 3, plug in 5, plug in 7. So when I plug in 1, I'm going to get y equals 30 minus 2 times 1. Well, 30 minus 2 times 1, 2 times 1 is 2. 30 minus 2 is 28. So I know it's one of these two, right? It's not going to be these two because they don't have a 28 in it. Let's go 3. Plug in 3 here. So if I plug in a 3 here, 3 times 2 is 6. 30 minus 6 is 24. So I know already just from this, it's going to be A. It can't be this, right? Oh, this has a 24 in it. Maybe. Let's try 5. When I plug in 5.
Yeah, but is it in the right order?
Yes, but technically it doesn't have to be in descending order. It just needs to be a set of numbers. It's nice when it is in descending order, though. So plug in 5 for x. 30 minus 10 is 20, and it is still A. You can check 7. Plug in 7. 2 times 4, or 7 is 14. 30 minus 14 is 16, so it's A. All right, so just make sure you know what domain means. Domain is the x values. Range is the y values, or the values you get out after you plug in your x values. Okay. What's the slope of the line that passes through R and T? Now, do you remember slope means rise over run?
Yeah.
Okay, it's the m value. If we do y equals mx plus b, the slope is the m value. It's rise over run. Or you can think of it as the difference between the y's over the difference between the x's, right? So if I am at a point, just count the rise over the run. So let's do it. What's the rise? 1, 2, 3. So the difference between the y values is 3. Now go over, the run is 1. 3 over 1. Now if I started here and I went down first and over first, I did the y values, this would be -3. And if I go back, that's -1. So if you go down and back, that's negative, which still gives you a positive number. A negative over a negative is a positive number. So either way you do it, this would be 3. Your slope is 3. All right, just make sure you remember slope. The intersection point of the graphs of the following systems of equation has an x-coordinate of 3 and a y-coordinate of 12. What information does the intersection point provide? All right, what does that mean? So let's say I have a graph. Ooh, I thought I was picking the straight line feature, sorry. Let's say I have a graph, okay? And they're telling me I have a system of equations, meaning I have more than one equation. It has an x-coordinate of 3, so over 1, 2, 3, and a y-coordinate of 12, so up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, way up here. Okay, so 3, 12. There's my intersection point, okay? What information does the intersection point provide? So I have, let's say, 2 lines. Say they're here and here. Okay. Oh, here's your lines. They gave you these lines. I could actually graph these. I didn't graph these, but I could. Okay. What information does the intersection point provide? Is it the solution to my system? Is it the y-intercept? Is it the slope? Or is it the constant of proportionality?
It's the y-intercept.
Okay. The y-intercept means it touches the y-axis.
Uh-huh.
Does this point touch the y-axis?
No.
No.
Sorry. This is a lesson from before. So
No, don't be sorry. We're just working through it. You can totally, this is what's great about math. You can totally just think about it, make the mistake, and then we walk through it so that you're like, oh, I see why it's not the y-intercept. I thought maybe it would be, but y-intercept means I touched the y-axis. So now let's think about it again. Could it be the slope of the graphs? Well, slope is rise over run. This one goes up, right? Up and over. And this one goes down and back. So this would have a positive slope and this would have a negative slope. So it's not the slope. I can already tell by looking at this one, the slope here is 4. Not the slope. It's the point.
Might be the solution of the system.
Yes.
Because it has an x coordinate and a y coordinate.
It is the solution to the system. It's the point where the two systems intersect. I can plug in 3 and 12 here and it will work. Check it. Plug in 12 for y and 3 for x. 12 minus 3 is 9. Check. It works for that line. Try this line. Plug in 12 for y and 3 for x. If this is 12 and I plug in 3 here, 4 times 3 is 12. 12 equals 12. Check. It's the solution. Yeah, that's what that means. All right. Let's go over what is this. Okay, so now I gave you a graph. Now you tell me what the solution is. Look at that graph and tell me what the solution is.
So the x is 3 and the y is 4. Negative 3, excuse me.
Good, negative 3. Yep. X is negative 3, y is positive 4. So negative 3, 4. There we go. That's it. And that's your point. Over 3 up 4. There's your solution right there. So you understood this when it was like this, but when it was given to you in this format, you were a little bit confused. But very similar questions. So make sure you understand that concept of finding the solution to the system. I didn't even have you find it. Algebraically, you could have plugged this into this and then told me what the solution was. Where do those two lines intersect? So make sure you understand that concept.
Yeah, I thought it was either the solution or the y-intercept. And I was like, oh, I forgot it.
And remember what y-intercept means. That means it's on the y-axis. So if it's a y-intercept, x has to be 0 to be on the y-axis. So, all right, let's look at 14. The table shows the number of tornadoes reported in the United States from 97 to 2007. Find the mean, the median, and the mode for the tornadoes. Tornadoes? They're like tomatoes, but they're tornadoes. Sorry. If necessary, round to the nearest tenth. Okay, so we just need to understand what mean, median, mode means. So mean, do you know what mean is? Mean is mean.
I think you have to like add them all and then multiply it by how many there are.
Add them all and not multiply by how many there are, but divide. Mean is the average. So you add them all up, add them all, then divide by the number of values. That's how you find the average. You add up, if you have 5 terms, you add them all up and then divide by 5. That averages them all out. So if one's high and one's low, it kind of gives them all an average. The median, think median is middle. And mode, I remember mode because MO means it's the most, the one that occurs the most. Okay, sometimes there's not a most. Everything occurs once and there is no most. All right, so in order to find the median, I have to line these all up in order from least to greatest. So I want to get through a bunch of problems. This is going to take me a while. I'm just going to tell you, review how to do it. To find the median, you have to line these up from least to greatest. So I would have to go like 941, that's my smallest. Then what's my next smallest? Let's see. It looks like it is this one, 1071. Then this one, 1074, and so on. Line them all up from least to greatest, and then you have to pick the middle. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms, okay? So if I'm just going to write out 11 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What would be the middle term? 1, 2, 3, 4, 5. There's 5 over here, and 1, 2, 3, 4, 5. So this would be my middle term. Now, if it's even number of terms, to find the middle, like let's say I had 12 terms, okay, then my middle would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My middle would be right here. So you would have to average these two, okay? So write them from least to greatest, find your middle. In this case, since there's 11 terms, your middle will be your 6th term, whatever it is. That's your first term, second term, third term, right? Your 4th, 5th, 6th, and so on. Okay, and then the mean, you got to add these all up and divide by 11. All right? Make sure you know how to do that. I'm going to go over the next one so we can get through more of these, all right? Which statement explains why it's reasonable to infer which doctor has the greater variability in weekly patients? So we're looking at our box and whisker plots. We got to know what they mean, okay? The line right in the middle, that literally is your middle. It's your median. If you line up from least to greatest, it's your middle number. Okay, the median. And then this is the median of your upper numbers, and this is the median of your lower numbers. Okay, so it kind of chunks it. That box is the middle numbers. It's the lower median and the upper median. It kind of is like where the big chunk of your stuff lies. That's what the box gives you. Now the whiskers is the very top number and the very low number. So if you look at
like the outline thing.
Yeah, if you look, they have the exact same range, right? The lowest number of patients they see is 8, and the most they see is 25. They're the same, okay? Now let's look at Dr. Lind. Dr. Lind, his chunk is wider in the middle. He's between 12 and 20, right? Where Dr. Gupta always sees between 14 and 19 patients. His median is higher. He usually sees around 18 in the middle, okay? His is lower because he can go all the way down to 12. Sometimes he only has 12, sometimes 20. So it varies greatly. So which statement explains why it is reasonable to infer which doctor has greater variability in weekly patients? Dr. Gupta's range is greater? No, they have the same range. Their range is the same. Nope. So this is the interquartile range, right? Dr. Lind, the interquartile range is greater. So Dr. Lind does have a greater interquartile range. Dr. Gupta, the median is greater. Yes, his median is greater, but it doesn't say why he has a bigger variability in patients he sees for the week sometimes. The median's a little greater. Yeah, that doesn't really tell me that he has bigger variability. Dr. Lind, the first quartile is greater. Okay, if you look at Dr. Lind, his first quartile is actually smaller than Dr. Gupta's. So it kind of brings us to this just because the other things aren't true. Dr. Lind has a greater interquartile range, meaning from the lower quartile to the upper quartile, there is a bigger range here. So that's why he has more variability in weekly patients, sometimes as low as 12, sometimes as high as 20 for that median grouping. Whereas his isn't such a wide range. He always sees usually between 14 and 19. Like his range is less small, right? He has greater variability, Dr. Lind. Any questions on that? Just make sure you can read these box and whisker plots and know what they mean. The median is the middle number, and this is your interquartile range. This says my data is more spread out. This one says his data is grouped closer together around the middle. Less variability. Okay, so let's go ahead and look at number 16. Find the total number of outcomes in each situation. The first year students at school must choose one of each of 5 English classes, 4 history classes, 5 math classes, 3 physical education classes. So you get to have all these different choices. So you have 5 different English classes to choose from. You have 4 different history classes to choose from, 5 different math classes, and 3 different PE classes. Okay, how many outcomes could you have here? So this is going to be the basic counting principle. Let's look at, we've got English, history, math, and PE. There's 4 spots. Let's go ahead and see, we've got 5 English classes to choose for the first spot. Does that affect, when I pick 5 English classes, does that affect what I pick for history, or do I still have 4 choices for history?
You still have 4 choices.
I do. So just with English and history, I'm going to multiply that together. That'll give me 20 different choices, okay? Now, let's look at our math classes. Picking my history class, does that affect my math class choice? Or do I still have 5 choices for that?
You still have 5 choices.
Yeah, so now I'm going to multiply by 5 more choices. Now, what about PE? How many choices do I have for that?
3.
Yeah, So I got to multiply these all out. That's a lot of choices, right? So really, you could have a ton of different choices here. First year students, one of each. All right, so if we did 5 times 4 times 5 times 3, I should get 300 different outcomes. So if you and your buddy are taking classes together, what's the chances you have all the same classes? Not very many, because there's 300 different ways you could pick classes, right? That's a lot of choices in this scenario. All right, let's go ahead and look at number 17. Antoine wants to know how often the residents in his dorm go to the beach. He's just curious, like, how often does everybody go to the beach? Because I like going to the beach and I'm just curious, okay? Let's do just a sampling. Let's see. Which sampling method will give valid results? So we want to know valid results, thinking about it's not a biased result. So think of this logically. What would give him valid results? Surveying his family and friends? Well, his family and friends could really love the beach or hate the beach, so it depends. Posting a question to the college website. Asking all the members of the swim team that live in his dorm. Okay, I want you to think about what biases each one of these would have. Or asking students in 3 random rooms from each floor in his dorm. Okay, what bias might surveying his family and friends give?
If he knows them, they'll probably say, like they like it for him or something like that.
Yeah, or because they're his family and friends, they might be biased to like going to the beach because he likes going to the beach, right? And that's why he's friends with them, because they like doing the same things. Okay, so that's a pretty biased question. Posting to the college website seems fair, but that will be only hitting people that are interested in answering that question on the college website. So it might just hit a bunch of people that like going to the beach. Like, ooh, look at that question. I like going to the beach. I'm going to answer that, right? It might not be as valid of a random sampling as you think, because you have to go to that website to answer that question. Now, asking all the members of a swim team that live in his dorm, what do you think about the swim team? Do you think they might be more biased to going to the beach?
Yeah.
Yeah, right. So that will be a biased sampling. What about asking 3 random rooms from each floor of his dorm?
That would be very random.
Yeah, that's going to give you more valid results. There you go. All right. Let's go to 18. So we got 10 minutes. Let's see. We only have 10 minutes. I have to log into my next session. I want you to look through and let's go over the ones that you want to go over next. Do you want to go over this one, the 5-card one? Or just look through it and see if there's ones that you're like, I really need you to do this one for me.
Maybe let's just do the probability ones, because I was having trouble with those.
Okay.
And then the rest, I can just watch old videos about to study.
Okay, let's do this then. Okay, so Natika has a set of 5 cards numbered 1 through 5. She shuffles the cards and chooses 1 card at random. She repeats the process several times and records the results in the table below. Based on her results, what's the experimental probability of choosing a 5? Okay, so she has a set of 5 cards numbered 1 through 5. So I like to draw it out just to help my brain. So I'm going to go 1, 2, 3, 4, 5. You got 5 cards, right? Draw it out. Okay, that helps me. She shuffles the cards and chooses 1 at random. She repeats several times and records in the table below. Oh no, I didn't give you the table. Huh. I gotta fix number 18. You can't do that one. I'm gonna go back and repost that. Poo-poo. I dropped the table. You can't do this problem without the table. Okay. Let me see if I had the table somewhere else and I could write it up for you. I'm glad I went over this with you. I didn't realize I dropped the table. Hold on. I dropped the ball on that, didn't I?
It happens.
Now Now I'm going to go double check and make sure I didn't do that on the final exam. Let's see what I have here on the final. Okay. Let's do this as the frequency. Let's go 6, 4, 5, 3, 7. This is a table I have. I think this is the table I was supposed to put in here. What's the experiment? So she records this. She pulls out a 6, then a 2, then a 3. This is how many times she pulled out. A 1, 6 times. A 2, 4 times. A 3, 5 times. So based on results, what's the experimental probability of choosing a 5? So she wants to choose a 5. How many times does that happen?
7.
7 times. Out of how many total times?
6 plus 4 plus 5 plus 3.
Yep, add these up. This is how many times she does it. 6 plus 4 plus 5 plus 3 plus 7. 6 plus 4 plus 5 plus 3 plus 7. So 7 out of 25 times. So remember, probability is your favorable, what you want, which I want. I wanted the 5. That happened 7 times out of the total number of times. Okay, favorable out of the total. So it happened 7 times out of 25 total times. So do the math on that. 7 divided by 25 is 0.28 or 28%. All right, so that's what I'll go back and put this graph in here. Okay, let's go over 19. A 6-sided number cube whose sides are numbered 1 through 6 is rolled. What is the probability of the cube landing on a 6? Wait, that was number 18. Fix that one. What's the probability of the cube landing on a 6 after the first roll and an odd number after the second roll? So if you have a die and you roll it twice, okay, does the second roll is it affected by the first roll? That's the question.
No.
It's not, because I just pick it up and roll it again, right?
Yeah.
So we want to know, what's the probability of landing on a 6? So the first roll, there are 6, it's numbered 1 through 6. So the favorable out of the total is our probability. The favorable, what's the probability of landing on a 6? How many times does that occur?
That would probably be 1.
1. There's only 1 chance to get a 6 out of 6 total chances, right? Out of the total numbers on there. Can't even spit it out. Yeah. So there's 1 favorable. It's the 6 out of 6 choices. Now the second time she wants an odd number. There are still 6 choices, right? But how many odd numbers are there on the cube? There's 1, 3, and 5. There's 3 odd numbers, 1, 3, and 5. So the second thing is 3 out of 6. So I'm going to have to multiply these two together to get the total probabilities. So if I multiply these, I get 3 out of 36. Now you can reduce this because 3 goes into 36 12 times, and this will be 1 out of 12. And that's how you do that one. Okay, 2 different probabilities. All right, let's see. Got a couple more minutes. Let's go over number 20. What's the probability of tossing a coin and landing on tails 3 times in a row? Okay, so you flip a coin. The first chance, we got 3 times, okay? So the first chance, you toss a coin. Probability is favorable out of total. So you toss a coin and you want tails. So what's the probability? What's the favorable? How many chances are there? Or how many choices are there?
2.
2. And you just want one of those choices. Okay, so you do it 1 time, then you do it again, same thing. Then you do it again, same thing. So you just have to multiply your probabilities together to get the total chances of it happening 3 times in a row. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 1 out of 8, that's the chance of it happening 3 times in a row. All right, we got a couple more minutes. Let me see if I can do a couple more. Parallel lines L and M are intersected by transversal T as shown below. Which of the following angles are congruent? You want to know if they are congruent. Well, we know corresponding angles. They're on the same side of the T of the transversal and in the same spot on their line, above the line, those are congruent, okay? Or below the line, same, those are congruent, okay? Same side, corresponding. Same side interior angles, those are supplementary. They're not congruent. Alternate interiors are alternate exteriors are congruent. Also, alternate interiors are congruent. Same on this side, alternate exteriors and alternate interiors. Oh, excuse me, not that one, that one. Okay, so knowing that, let's look at 1 and 4. 1 and 4 are actually congruent because they're vertical angles. Okay, so yes, 1 and 4. How about 1 and 2? Well, 1 and 2 are supplementary. They are not congruent. How about 4 and 6? 4 and 6 are same side interiors. They are not congruent. 6 and 8 are supplementary. They make up a line. They are not congruent. Unless those are both 90, they're not congruent. So it's going to have to be 1 and 4. Those are vertical angles. All right. Let's go ahead and look at square DEFG has these vertices. What are the coordinates of point G? Sometimes it's best just to draw yourself a little picture so you can see it. Okay. So if you have, let's go 1, 2, 1, 2, 1, 2, 1, 2, because you only have 2, right? So you go 0 up 2, there's D, over 2, 0, there's E, 0, negative 2, there's F. What's G going to be if it is a square?
That's going to be, so X will be 0, and then no, Y will be 0, X will be negative 2.
Yes, negative 2, 0. It's going to be negative 2, 0. Well, there's a lot of A's, huh? Okay, let's go over 23.
I think it's 11 o'clock.
Okay, last one. Let's go over this one. Find the sum of the measures of the interior angles of each polygon. And then they ask specifically a pentagon. The sum, we just know the sum, a pentagon is 5 sides, right? Okay. The sum of the interior angles is the number of sides or number of angles minus 2 times 180, right? So if there's 5, we're going to go 5 minus 2, which is 3, and 3 times 180 is 540. Okay. All right. I'm going to go ahead and let you go. If you have more questions, I have another review session that's open for everyone on Thursday at 11. So you can be like, I'm going to work on these. I'm still not sure about a couple of them. Pop into my review session on Thursday at 11. All right.
Okay, thank you. Appreciate it.
Okay, good luck and have a good day.
You too.
Okay, bye-bye.
Bye.